Welcome to tonight's video on section 10.3, geometric sequences. A geometric sequence is a sequence that differs from arithmetic in that after the first term, the next terms are obtained by multiplying the preceding term by a fixed constant. So for example, a geometric sequence would look like 1/1/2, 1/4, 1/8, 1/16, and so on, where you're multiplying by term to term by a common number of 1/2. Or another example would be 2, 4, 8, 16, 32, 64, and so on, where here you're multiplying by 2 to go from one term to the next. But the key is you're multiplying by a common term as opposed to arithmetic where you're adding or subtracting by a common term. And that common term that you're multiplying by is what's called the common ratio. So that is the number that is multiplied to obtain the next term. And you can get that common ratio by dividing the second term by the first term, and that gives you the common ratio. So here we have, it says write the first 6 terms of the geometric sequence, which the first term is 12 and the common ratio is 1/2. So the first term is 12, so the second term would be 12 times 1/2, which is 6. The third term would be 6 times 1/2, which is 3. Fourth term, which would be 3 times 1/2, which is 3/2. The fifth term would be 3/2 times 1/2, which is 3/4. And the sixth term would be 3/4 times 1/2, which would be 3/8. To find any term of the geometric sequence, you can take the first term and multiply it by the ratio to the n-1 power, because that's how many times you're going to multiply by the ratio to get whatever term you're looking for. So what you need are the first term, n is the number of terms, and r is the common ratio. So if it says find the 7th term of the geometric sequence, if the first term is 5 and the common ratio is -7, so you would find the 7th term by taking the first term, which is 5, and multiplying it by -7 to the 7 minus 1 power. So it's 5 times -7 to the 6th power. And when you multiply that out, you get 588,245. That is your 7th term. Writing a formula for the general term of a geometric sequence. Well, the first thing you want to do is figure out what the ratio is. And here the ratio is 2, because you could do 6 divided by 3, or you could notice that you're multiplying by 2 to go from term to term. The first term is 3, so to write a formula for the general term, you would take the first term, which is 3, and multiply it by the ratio to the n-1 power. So there is your formula for the general term of the sequence. To find the 8th term of the sequence, you would substitute in 8 for n. So it's 3 times 2 to the 7th. So when you multiply 3 times 2 to the 7th, you get 384. To find the sum of the first n terms of a geometric sequence, what you would also need is the first term. You would need to know the ratio, and you would need to know the number of terms which you're finding the sum for. Because remember, in a geometric sequence, since it goes on forever, you would not be able to find the sum of a geometric sequence unless it was a specific situation, which we'll talk about in a little bit. So, the first question says, find the sum of the first 9 terms of the geometric sequence. Notice the first term is 2. The ratio is -6 divided by 2, which is -3. And there are 9 terms. So the sum of the first 9 terms would be the first term times 1 minus -3 to the 9th over 1 minus -3. Well, 1 minus -3 to the 9th is 19,684 times 2 gives you 39,368 over 4. So when you divide that by 4, you get 9,842. So that would be the sum of the first 9 terms of the geometric sequence. So if I wanted to find the following sum, notice here there are 8 terms. It's geometric because the ratio is being raised to a power. The first term, 2 times 3 to the first. So the first term is 6. And the ratio, what you multiply, it would be 3. So the sum of the first 8 terms of this would be 6 times 1 minus 3 to the 8th over 1 minus 3. Well, 1 minus 3 to the 8th is negative 6,560 over -2. Well, then you multiply it by 6, and you get negative 39,360 over -2. So when you divide by -2, you get 19,680. That would be the sum of the first 8 terms of that sequence. So just like with the arithmetic sequence, the geometric sequence has word problems. So if a job pays a salary of $30,000 the first year, and during the next 29 years the salary increases 6% each year, what is the total lifetime salary over the 30-year period? So in this case, the first term, the initial salary, is $30,000. And then It's increasing the next 29 years, so that means you're going to add, 30 years. You're going to add all 30 years together. And the increase is 6%. And when it increases, like if you want to see what the raise is, you don't multiply by 6%. You multiply by 1.06 or 106%, because that means the salary is going to be 106% of what it was the previous year. So when you use, the ratio is going to be 1.06. So we're going to put this in the formula here to find the sum of the 30 years that the job pays. So we're going to go 30,000 times 1 minus 1.06 to the 30th over 1 minus 1.06. So when you multiply 30,000 times 1 minus 1.06 to the 30th power and divide that by 0.06, or 1 minus 1 point, actually it's negative 0.06. You get approximately $2,371,745.59. So you could say approximately $2,371,745 is how much you will make in that 30-year period. Now, we talked about the fact that you would need a finite amount of terms to find the sum of a geometric sequence. The only exception to that is basically if the ratio of that geometric sequence is between -1 and 1. Because if that happens, basically when you keep adding terms, it doesn't affect the sum. And that is the only time you can find the sum of an infinite geometric series. So the ratio is going to have to be between -1 and 1. So basically, if R is between -1 and 1, then you can find the sum of the infinite geometric series by knowing the first term and the ratio, because there is no n because it's infinite. So for example, if you want to find the sum of 3 plus 2 plus 4/3 plus 8/3, well, the first term here is 3. The ratio is 2 over 3. So, and that is between -1 and 1, so therefore you can find it. So the sum is going to be 3 over 1 minus 2/3. So it's 3 over 1/3, which is 3 times 3, which is 9. The next one, if you look at it, the first term here is 3/8. The ratio is -3/16 over 3/8, which means you multiply by the reciprocal. So basically the ratio is -1/2. So when you find the sum, it's 3/8 over 1 minus -1/2. So it's 3/8 over 1 minus negative 1/2 is the same as 1 plus 1/2, which is 3 halves. When you multiply by the reciprocal, you get 1/4. So the sum of that series is 1/4. Now, you can use this to help you change a repeating decimal into a fraction. Because this repeating decimal is the same as 0.7 plus 0.07 plus 0.007 and so on. So that's why it's a geometric series. The first term in the sequence is 0.7 or 7/10. The ratio, the common ratio, if you look at it, 0.07 or 7/100 divided by 7/10. If you take the reciprocal, is 1/10, right? Every time you're adding a tenth to this. So to find the sum, you take the first term, which is 7/10, over 1 minus 1/10. Well, 1 minus 1/10 is 9/10. And then you take the reciprocal, and that means the fraction is 7/9. That produces that decimal. So if you do the next one, 9/10, so it's 0.9 plus 0.09 plus 0.009, or in other words, 9/10 plus 9/1000 plus 9/100 plus 9/1000. So the first term is 9/10. The ratio is 1/10. So you have 9/10 over 9/10, which gives you 1. All right, that concludes our video for today, and I will answer any questions you have in class. Thanks. Bye.